Hey everyone, my name is Ronak and this is Python programming tutorials right from the scratch. This is tutorial number 14 and in this tutorial we will have a look at the math module. So the math module is basically an inbuilt module in the Python. So let's begin. So like I said in my last lecture, in my last tutorial, it says import space. The name of the module is the right way to import the module inside a program, and now you can access it. You can access the functionalities of this module. So let's begin with constants. So what I will be doing is I will try to teach you some of the basic functions and methods that I actually know, and let's begin with constants. So let's say mat.py. So what it will do is it will give us the value of the pi. So the value of the pi is 3.14. Yeah, and now what you can do is, this is a constant, so you can use it any way you want. So you actually don't need to type like the 3.1.4 and blah 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 till here. What you can do is mat.py, so it will take the value and you can perform any operation. Yeah. So next we have the exponent, and the value is 2.71. In the same manner like the operation I performed over here, you can do it over here too. Yeah, this works. So next I would like to discuss is mat.tau, and what this tau is basically represented as the 2 pi. So whatever the value of the pi is, it is 2 pi. See? Okay. Now next let's begin with functions now. So the first function is mat.ceil, and what this does is it will basically round the number, like the decimal number, to the upper bound. So if we have 18.5, it will give us the output 19, because ceil actually means to the top. In the same manner we have mat.floor. It bounds the number to the lower bound. So floor pretty much indicates downwards. Yeah. Now the next I would like to tell you is something known as mat.copysign. Okay, so this takes two parameters, x and y. The x over here is basically the absolute value in the form of float, and the y over here returns the the sign in the form of float. So let's give it a try. So let's say -1, and over here let's say -4, and it says -1 because it pretty much uses the sign of this, the sign, like if it would have been positive, copy sign, and let's say -1 and 4, it will give us the positive. So it converts this first number to the absolute value in the form of float, and then it uses this sign of the y. Good. Next we have something known as mat.factorial. Now what really a factorial is? So factorial is a number. So first of all, let me tell you what factorial is. Factorial is represented by any number followed by an exclamation, and how it performs itself is, it says 3 multiply by 2 multiply by 1. So it goes down the way, so it can be any number. Like if it is 5 over here, it will say 5 multiply by 4 multiply by 3 multiply by 2 multiply by 1. So the factorial of the 5 is 120. So in the same manner we can enter any number over here and we can get the factorial. So let's say the factorial of 5, and it is 120. Okay. Next is something known as mat.fabs. So FABS, and it gives the absolute value in the form of float. So let's say -4, and it is 4. Okay. Now another function that I would like to tell you is mat dot GCD. GCD is pretty much known as the greatest common divisor, and GCD over here takes the two parameters x and y, and what it will do is it will compute the greatest common divisor of the two numbers. So let's say 48 and 36, and it should be 12. So the GCD is 12. Yeah, it works. So these were some basic functions. Now let's move on to the power and logarithmic functions. So first of all, let me tell you something known as mat dot. It is pretty much hard to remember. So yeah, exp function along with x. So what it will do is it will take the value of the x, like the value of the x will be the power to the exponential function. So what if we type over here 1? So it will be like, okay, the exponential constant is 2.7.1 raised to 1. In the same manner, we can enter any number we want and we will get the output. So let's say 3. Yeah. So it said that exponential function multiplied by exponential function and multiplied by exponential function. Just because it was 3, it will compute it thrice. Okay. Next function is mat dot exp m1, and what it does is it will first of all compute the power. The x is the power, and it will subtract it from 1. So let's say over here 1. So what it did was, the 1 over here is basically the power of the exponential constant, and then this exponential constant was subtracted by 1. So the output was 2.7.1 and blah 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 minus 1. So it gives us this. So this was the basic exponential function. Now let's move on to the logarithmic. So let's say mat dot log, and this takes two parameters. It says x and the base. Now there are two ways you can execute this. If you only type x, it will give us the base. It will give to the base e. So let's say log 2, and it returns this value to the base e. And if we give it two parameters, let's say 2 and 10, so what it will do is it will say, okay, so this is log x, and the value is 2, so 2 to the base 10, and this is the value. Now next I would like to discuss something is known as power. Now in my previous examples you would have seen something like this. So what I did was I multiplied 8 to the power 3. So instead of doing this, you can also do it in math, POW, and it will take two parameters x and y, where x is the number and 3 the y is the power. So let's say 8 and 3, and it will tell 5 and 2. It will give us 5 and 2, but this is in the form of float. If you want it in the form of the integer, you can use the the asterisk thing that I taught you. And the last power and logarithmic function I would like to tell you is mat dot sqrt. I gave you an example in the last tutorial, and let's say 144. It will give us the square root. The answer would be 12. Yeah, this works. Now let's move on to the trigonometric functions. Now it will compute the value of the trigonometric. So let's say sine. So the math of this, so sine 0 is 0. In the same manner, we can enter any number over here, and cos 0 is 1. Yeah, it works. We also have mat dot tan. Yeah, this really works. And we have something known as mat dot a tan. Now what this is basically the arc. of the tan. So let's take 0. Yeah, it will return 0 definitely. Now next method, I have to recall it. Mat dot hypot. So this basically computes the Euclidean norm, and it takes two parameters x and y. So let's compute something. So let's say now another method that I would like to tell you is, now let's move on to the angular conversion. This is also one of the methods present in it. So it will give us the from degrees to radians and radians to degrees. So let's first of all compute degrees, and in this function radians will be converted to the degrees. So the 1 radian is equivalent to the 57 degrees, like 57.29 something. Yeah, in the same way we have mat dot radians, and 1 radian is it will convert, this radians function will convert degrees into radians, and 1 radian the one degree is equal to 0.017, I think. It is 0.01745 blah blah blah. Okay, now let's move on to the hyperbolic functions. Hyperbolic, we actually did some trigonometric functions, sine, cos, and hyperbolic is basically just adding h. So let's say 0, it will say 0. You can enter anything over here basically, like cos hyperbolic 30. Then we get the answer. In the same manner we have it for tan 2. So let's say tan hyperbolic 60, and it says 1. Fine. Okay, so these were some basic function and method. Now next thing, the last thing I would like to discuss is something known as special functions, special purpose functions. So these are little bit advanced, and the functions that I'll be using over here are pretty much used in advanced mathematics. So something known as ERF, which is known as the error function, and it takes one parameter, that is x. So let's compute for 2, and this is the error function. In the same way we have mat dot ERF and C. Now what this C represents is, it represents the complementary error function. So this is the complementary error function. And the another method that I would like to tell you is, let me recall it. Gamma. Mat dot gamma. So this is the gamma function. It will take the one parameter and it will return us the gamma function. So this is the gamma for 2. In the same manner we have something known as mat dot L gamma, and this is also known as, so what it will do is, it will take the value of the x and it will give us the gamma of the logarithmic of the absolute. It will logarithmic of absolute value of the gamma. So let's say 2 and it says zeros. So these were some of the basic function, methods and constants that I thought I taught you, and so that's all I actually know about the math operator. The math module, and I actually covered a lot of things over here today. So what you can do is give it a try. Try practicing some of them. It is really fun. So in the next tutorial I will be covering some more inbuilt modules. Till then, goodbye.